Okay, thanks Stephanie, and thanks to the EPA for funding the project. This was a 12-month project with the broad title of Green and Blue Spaces and Health, a Health-Led Approach. This is the team here with the key workers being our postdoc, Dunstan, our auditor. So the broad project summary was we had 5 work packages: a literature review, a kind of health data audit to help identify possible usable sources of data and also help us identify sites of interest. We also looked at a number of different possible sources of GBI data, or green and blue infrastructure data, and then we carried out essentially some spatial statistical modelling, overlaying the health data with the green and blue data. So it's not dissimilar to Anne's project, but rather hers is individual based, ours is area based. So interested in that kind of associational effect as well. The other thing to say is that most of the work in this area has tended to be GBI led, i.e. people start with the green and blue infrastructure side and then kind of think about the health afterwards. We wanted to go the other way around. We wanted to use the health, or particularly the health data, to drive the modelling. So it's kind of reverse the kind of I suppose the direction of that work. And the ultimate aim of the project was to provide some quantitative evidence of association between health and GBI for different scales and configurations. So we were working across 5 different geographical scales, so it's very much a cross-sectional area-based study. The literature review, we did a small-scale scoping review using the term health-led, or using that or associated set of terms to look through the literature. And there was quite a small amount of literature, if you like, that focused very much on a health-led perspective. There's certainly a lot of literature around the magnitude and type of place-derived health benefits, but again, this again seems to come more from the GBI side than from the health-led side. So in looking at health-led studies, we identified different types of measured, self-reported and proxy health indicators as being quite important things to look for. But also I think, and it was kind of gratifying because this was our experience as well, was access to meaningful health data at multiple scales was identified globally as an ongoing constraint. So the health data is always a bit of an issue. And certainly the literature also identified the need for some fuller investigations across geographical and temporal scales. So we took that as a guide to the kind of work we wanted to do. So this is a very broad schematic of the sort of health data audit and site selection parts of the project. On the left-hand side, these were the kind of drivers in terms of health data. And I know we're going to have a conversation after lunch around this topic, so I'm not going to spend too much time on it because I think it'll be an interesting discussion. But the kind of things that would shape one's access to health data are around availability, accessibility, and for us, crucially, the ability of a meaningful spatial reference, the notion of a spatial tagged data, health data that is spatially tagged almost as it's collected or as it's disseminated is for us a very important component. And then on the right-hand side, we and I'll talk a bit more about in the next few slides, we carried out specifically some spatial cluster analysis to identify, to strip out and zoom into the health data, to use that to identify possible locations for our studies. And then we kind of put those two things together and did the modelling as the last part. So these are examples of some of the data sets we looked at. We certainly looked at things like TILD and GUI, but we decided against using those because we wanted to focus more on the area-based data. We explored the possibility of accessing of what kind of measured data was out there, what kind of proxy data, and what kind of self-reported data. So a lot of these came from statutory sources, so the census in terms of the general health question in the census, the disability question, and a derived variable we produce in Maynooth called the KFIW index. Things like deprivation and other socioeconomic indicators are obviously important elements as well. And perhaps one of the key data sets we used was mortality data collected from a project run by Jan Rigby at Maynooth University, where we mapped mortality data to what was an intermediate area scale, a geography not that well known, and I want to talk a little bit more about that. So these were the kinds of data sets we were exploring. Just to say, there's a particularly good piece of work by Conor Gelger and his team through HICWA, which is a really good data audit. So we didn't want to reinvent the wheel. That HICWA data audit is very strong, and indeed the EPA SAFER audit is also very, very useful. So there's a couple of very good sources. But just to show you the geography, this is what the intermediate area geographies look like. This is a map of premature mortality under 75 at this intermediate area scale. So you can see what it is. It's a geographically modelled aggregation of EDs. So it's about 5 or 6 EDs in each intermediate area. So it's a kind of a scalable geography that you can build data onto. You can scale it up using GIS tools. You can aggregate up to this scale for the modelling. This data was reported a number of years ago, and there's a paper in Irish Geography on this if anyone's interested as well, and got quite a lot of attention because of the very strong associations between mortality and areas of deprivation. So this is very evident from the map. On the right-hand side, you have the newly available self-reported health data from the census, first carried out in 2011, now available in 2016 as well. So you got it for 2 time periods. Amazingly, Irish people are incredibly optimistic. Our reporting of very bad and bad health is around 1.5%. In all of the other British Isles jurisdictions, including Northern Ireland, it's 5 to 6%. So either we're incredibly optimistic, but I think it's actually explained by the fact that the average age in Ireland is about 3.5 years less, and I think that sort of possibly is a more clear explanation of that. But these were just an example of some of the different scales we were doing the modelling at as well. We used cluster analysis, particularly using, we tested a number of different cluster techniques, but we used one called Ansel and Local Moran's Eye. And essentially what cluster modelling does is it looks at health data, geographical health data at multiple scales, and looks at clusters of areas with bad health surrounded by other areas with bad health, areas with good health surrounded by other areas with good health, and also interestingly picks up 2 intermediate types of areas, which are areas with poor health surrounded by areas of good health, and areas of good health surrounded by areas of poor health. So kind of outliers in a sense. We did focus our modelling, however, on the red areas here, the areas with clusters of bad health, and on the blue areas, clusters of good health. And also, if you compare visually with a map of deprivation scores, there's a pretty strong association between those 2 indicators. So again, we didn't use deprivation for identifying the study areas, but we did use it when we were doing the modelling subsequently. So in terms of how the actual modelling was carried out, we went and looked at a number of different sources of GBI data, including Careen, Urban Atlas, like Anne had used as well, and also some additional satellite data. Some of the constraints around the kind of GBI data we were looking for were to do with geographical coverage, classifications of GBI, affordability, some satellite data needs to be bought, and the levels and amount of pre-processing required. And ultimately we selected Careen and Urban Atlas to use in the modelling depending on the scale that we were working with. And then we used GIS-based iterative spatial models to essentially do an overlay from the health data which was gathered at these multiple scales. So this is a little graphic of one of our study areas in Cork City with the intermediate area boundary, the ED boundary and the small area boundaries within that, and then we were essentially overlaying that and cutting that through the underlying GBI data here, which contains information on green and blue space, and producing some essentially statistical associations from those overlays. So what we ended up doing was doing some modelling at 5 different scales, at local authority or county scale, at settlement scale, at intermediate area scale, and then also at ED and small area scale. I have to say that the small area scale was not that successful. It was almost too small to do modelling at, and we found probably the best scale to do our modelling at was the intermediate area. It was a nice kind of compromise between detail and data. So again, I'm not going to go through this in any great detail, but there's just a couple of graphics on results. The broad, bigger picture story in terms of the reporting was that we generally confirmed broad associations of good health outcomes across the different scales with the presence of higher amounts of GBI. So there was a relatively strong association at all scales of the availability and amount of green and blue space with higher health indicators. So it does confirm that very broadly. There was a slightly stronger association with green over blue space, which was kind of interesting for us to explore. There are also, I also have a set of statistics in here. They're far too small to read on the screen, but it's really more to make the point that what we have is we have different scores across different scales of analysis and different time periods. So we did succeed in doing that sort of multi-temporal, multi-scalar part. It's not as complete perhaps as we would have liked, but we made reasonably good progress depending on the data that we had. So I just want to finish off really with a couple of broad findings and limitations, and also some recommendations, I suppose, to tease out some of the stuff that we felt was interesting coming out of this work to move forward into wider discussions, particularly around health data. So I think there was a broad magnitude of effect identified. There was certainly the project worked as a kind of proof of concept to show that it is possible to identify some statistical indicators and associations of the relationship between health and a range of different health indicators and GBI data. We modelled it across different scales and time periods, but we think there's plenty of scope to develop and move that on as well. For me, it is a long-standing thing of mine, and it certainly feeds into this afternoon's discussion. We need to develop and progress more spatially tagged health data, consider its release in aggregated form, and we might have that conversation later on today as well. One of the concerns that people have about health data is that it's very sensitive, we know that, so individual level health data is particularly sensitive, but if you aggregate it up to reasonable levels of reporting, then that privacy is guaranteed. But what you're doing is you're building up robust data from the bottom up rather than modelling it from the top down. So I think that's a big thing for me. We were very interested, for example, with the disability data, which I think is an underexplored data set in terms of some of this kind of modelling work. The figure release that's made available at small area in the census is the percentage of people who declare any disability under question 16 in the census, and that ranges from sight impairment, hearing impairment, to chronic illness, to mental health. We also did a data request to the CSO to ask for some of the specific answers to question 17, which record those specific conditions. So we were able to, for example, map the percentage of people with emotional or psychological conditions modelled down to ED level, but again, that's really sensitive data, and they will not release it at small area level, as far as I understand. We were interested in that. We were also interested in modelling it in terms of change over time, so we're actually looking at shifting variations in terms of disability levels across time. So again, this is slightly developing on from what the project was looking at, but some interesting potential. And I'm going to finish with my last 13 seconds, because there's a timer here, with just a couple of recommendations. I'd like us to think about this idea of new reporting geographies. The other option from a HSE point of view is there are LHOs, which I believe are not as widely used as they were, primary care networks. So you're talking about primary care networks, around 90 nationally. Average population is about 50,000. That might be a very interesting reporting scale. The tools are there in GIS to aggregate up to this data level. The other thing is start using AirCode a bit more. This image on the top right is a map of percentage of registered population dispensed with an antibiotic in Northern Ireland, because they have really good postcodes and people use them. So there's a long history of using postcodes. I think what's fascinating about this map, if you know the geography of Catholicism and Protestantism in Northern Ireland, look at that pattern and tell me what you think. I think it's a really interesting pattern. And then the other one, which is really interesting, and I really want to thank my colleague Ronan Mahoney, who works in UCD on this one. He's mapped hype data. So he's worked with St. Vincent's University Hospital to actually map the individually georeferenced hype data just for people presenting in the emergency department for over the age of 65. So this is what you can do. So this is a map of the catchment of one particular healthcare demand for one particular subpopulation. This is the kind of stuff you can do with GIS and good spatial data if we can get at the data. Thank you.